So yesterday we completed this mixed partitioning, and today we are moving now to the next slide. That is the next topic, that is UDF, user defined function. In yesterday's class we used like count method. Method or function both are the same thing. So we used count function that is inbuilt in Hive. Just like count, we have minimum function, max function, average function, lowercase, uppercase. There are so many functions available. But that is something which is already there in Hive. Can we define something from our end? Suppose there is a requirement and the requirement cannot be fulfilled with the help of existing Hive functions. Can we write our own UDF? Can we write our own user defined function? Yes, we can do that. As discussed in a Hive introduction class, Hive gives us the flexibility to extend the feature. In case you have some new requirement and if you want to write a UDF for that particular requirement, you can do that. So let's check it out. Just for example, I am doing select first name from employee and it is giving me the output Neeraj, Shravan, Murugan. But somehow I want to convert these names into uppercase. I can do that with help of existing inbuilt Hive function, that is upper. So select upper first name from employee. What it will do? It will not change anything into your table, but while displaying it will convert these names into uppercase. You can see now Neeraj, Shravan and Murugan, all these three names are displayed in uppercase. So this has been possible because of upper function. But this is something which is inbuilt in Hive. So we will be writing our own UDF as per our own requirement. So there are two types of UDF. One is temporary UDF, that is temporary user defined function, and another one is permanent user defined function. So we will explore these two things in more detail in the coming slides. Okay, first the next is get currency UDF. First of all, let's talk about the requirement. The requirement is I want to convert the country name into its currency. Okay, do we have any inbuilt Hive function which can convert country name into its currency? No, it's not there. But our client has given such requirement that we need to convert the country name into its currency. That means for this specific requirement, we need to write our own UDF, our own user defined function. So this is completely a Hadoop developer activity. This code is completely written in Java, but still we can have a quick look on that. That is quite simple. So starting from the first line, package UDF. You know that every Java program is we can put into a specific directory. Just like our word count program was placed in examples directory. Similarly, this Java program we are putting in UDF directory. That's why the first line is saying that the package for this program is UDF. Okay. After that, few import statements which are required for writing this program, like hash map, map, description, all this thing. The next is description. That is an optional component. If you want to provide the description for your UDF, you can provide this. This will help other team members to understand what your UDF will do. You have written your UDF, that means you know what your UDF will do. But other team members might not be knowing the purpose of this UDF. So we are providing the description of this UDF, and with the help of a command, this description can be displayed in the terminal. I will show you that practically. But again, This is an optional component. If you don't want to write this much of code, you can simply leave that. That's not required. Now the actual coding starts. Public class get currency extends UDF. Get currency is the class name which I have given. You can give any name. You can give ABC or XYZ. Just to making it meaningful, I have given the name get currency because this UDF will be used to get the currency for the given country and extends UDF. Just like in our word count program, we were extending mapper and reducer class, because in Java, if some features are already available in some class, you can simply extend that, and this way you can inherit all the features of that class in your class. So UDF class is written by Apache team, and what I am doing is I am writing my own UDF class by extending their UDF class. So okay, inside my class definition, one thing I have taken is map, static map string comma string. Map is a collection of key value pairs. You must be aware about key value concept. We have a key, we have its value. We have another key, we have its value. So a collection of key value pairs is known as map. String comma string means the data type of key is string and the data type of value is also string. The name of the map is country underscore currency is equal to new hash map string comma string. Okay, what exactly I am doing with this map? Actually, I am storing country and currency information in this map. There is no magic. There is no magic which can tell me the currency for the given country. I have to store somewhere like this is the currency for this given country. And when I will be using this UDF, basically I will be providing the country name as input, and based upon that country I will be finding out the currency from this map, and that currency I will be returning back. So basically writing a UDF is not a magic. We are not doing any magic stick. We are simply taking the country name, we are searching into our map like what is the currency for that given country, and then the particular currency we will be returning. So I have added few country and currency to this map. You can see country underscore currency dot put India comma INR. India is country name and INR is the currency. Similarly, the next USA is the country, USD is the currency. Then UK, GBP, Spain, EUR, Dubai, and like this. So basically I have stored few country name along with their currency. This is my static data. This does not contain any logic. I have just declared one map and I have stored few country currency information in that. Now the next and the most important part of this UDF is public string evaluate string country. When we are calling this UDF from Hive, ultimately this method, this evaluate method will be called. And what I am doing is I am passing country name as input to this evaluate method. And what it's doing, return country underscore currency dot get country. On a map, when you are calling a get method and when you are providing the key, it will provide you the value. So you are providing the country name. That country name I am passing to the map. Map will tell me the currency of that particular country, and that particular currency I will be returning back. So when you will be calling this UDF from Hive, you will be providing the country name, and this UDF will return back the currency for that given country. And that's our purpose. We are writing this UDF just for that purpose only. We want to get the currency for that particular given country. So this is the Java code for my get currency UDF. In case you are having any doubt in any of this line, you can ask me. Okay, so we are moving to the next slide, that is temporary UDF. So in order to use temporary UDF, first of all, we need to create a jar of our UDF. So when we talk about how to write our first MapReduce job, in that class we also talked about how to create a jar of a Java program. So whatever Java program we have written in the last slide, we can create a jar of that. And moreover, I have already sent that jar to you over email, so you can simply download that jar and we can use that. Okay, so that is first step. Second step is run the following command on Hive CLI. CLI means command line interface, that is Hive terminal. The command is add jar, then path of the jar, /home/nearest pdf /hive/udf_example.jar, semicolon. This is the path where I have put my jar. You may be downloading your jar from your email to your desktop, so you need to give the path accordingly. So that is second step. The third step is create temporary function name that may be different from your class name. I am using get currency as your class name, the complete class name including package. So udf.getCurrency. So this getCurrency, udf.getCurrency, this is my class name. But this getCurrency is the method name which I have declared for use in Hive. So these two may be different. And once you have created a temporary function, you can use that in your query. So let's do this thing practically so that we can understand the concept in more detail. So I am opening my terminal. Yes, Hive terminal is running. So what I will do is, first of all, let me clear the screen. Yes. Now let me copy the command from PDF itself. I will copy this. Add jar and then the jar path. So I am copying this. Okay, so I have executed that jar, and with the help of that one, this has been added to our Hive. Now the next command is create temporary function. So let's type that command so that we can understand it. So create temporary function then function name. You can use get currency or any other name. So let's use that one only, get currency as, in single quotes you need to provide the class name, that is udf dot g is capital, c is again capital, get currency. Okay, and ending with semicolon. Enter. Okay, okay means this command has been successfully executed. Your UDF has been created. Okay. Suppose I am another team member of my team and I haven't written this UDF. I don't know what this UDF will do. Can I describe it? Yes, I can do that. You can use describe function space function name, that is get currency. Okay, get currency, ending with semicolon, press enter. Yes, you can see now. This function can be used to find currency for given country. This line is coming because we have written the description in our Java code. In case you will not provide that description, no one will be able to describe the function, but they can still use the function. They will only not be able to describe it. Okay, so this was all about how to add the jar and how to create the temporary function. Now coming to the point how to use it. Just like we are using upper, lower, min, max, count, Similarly, we can use this. Let's check it out. I am doing select country. What I want is I want country name along with its currency from my table. So I am doing select country, comma. Now I will call this UDF currency. I will provide country as the input. Okay. So select country, comma, get currency for this country from my table, that may be click underscore history ending with semicolon. Okay, that's quite simple. We can press enter now. This query will be converted into MapReduce job and the output would be displayed over the terminal. Okay, one mistake I have done is I have not given the limit. That is not a mistake, but this command will calculate the country for all those 50,000 rows. So as we have not given the limit, let's wait for the output. Okay, so it will display 50,000 rows. That might take some time, but anyways, the output is in front of you. We have the country name displayed along with their currency, which is getting displayed continuously over the terminal because it will display the complete 50,000 countries along with their currency. Okay, that is done now. And you can see the output, the last line, fetched 50,000 rows. In these few seconds, it has counted the currency for all those 50,000 rows. So this is about temporary UDF. One question which may be coming into your mind is why these are called temporary functions. The reason being is every time you are opening your Hive terminal, you need to execute these two commands that I have highlighted in red fonts. This adding the jar command and create temporary function, these two commands you have to execute in every Hive session. You will close your Hive, you will stop your Hadoop, you will shut down your system. The next day you are again starting your system, starting your Hadoop, starting your Hive. Again you need to execute these two commands. Now the question is, just like we can use count, min, max, uppercase, lowercase without adding any jar, without creating any function, can't we use our own UDF like that? Yes, we can do that. And those are known as permanent UDF. We have to do some steps, and once those steps are done, you never need to add the jar, you never need to create the temporary function. You will be able to use your defined function just like you are using any inbuilt functions of Hive. So the next we have is permanent UDF. So just like we had written a code for our UDF, we need to do that. We need to follow these steps to use those UDF just like we are using any inbuilt UDF in Hive. So let's check it out the step. The first step is extract the content of hive-exec-0.8.1.jar from Hive lib. In Hive lib directory, you will find one Hive execution jar. Depending upon your version, I think the latest version is 0.11. So you can find hive-exec-0.11.0.jar. You need to extract that. Why we are extracting that? Because this is the jar which contains inbuilt Hive function. We will extract that. We will add our own UDF and then we will again create a jar of that. So ultimately our UDF will be added to this jar. So this is the first step, extracting the content. Second is modify the Java file function registry.java. You know that jar is nothing but a collection of Java programs. So inside that jar you will find this program function registry.java. And as the name indicates, this Java program has the registration for all UDFs, all Hive functions. So it already contains all the inbuilt functions of Hive, we just need to add our UDF. So we will add the line register UDF, the UDF name whatever you want to use, suppose get currency, comma your class name UDF dot get currency dot class. So this way, whatever number of UDF you are planning to add, you need to add line for each UDF with their name and with their proper class name including the package. So this is the third step. Fourth step is add the class files of your UDF with proper directory structure. We have added the line, that's fine, but we need the code of your UDF as well. So along with the proper directory structure, because you have a PDF directory, inside that you have this get currency class. So with the proper directory structure, add your Java programs, add your Java classes to this jar. You can simply copy it at this location, and once you have copied it, we will create a new jar again. But now the only thing is, new jar has the updated function registry.java which contains the information about our UDF, and this updated jar contains our Java programs as well. So we can create a new jar, and once the new jar has been created, we can put the jar back to the original location, that is Hive lib directory. So now your updated jar has the information about inbuilt function as well as our user defined functions, along with that coding of our programs. So after doing these steps one time, you can use your UDF just like you are using any inbuilt Hive function. So this is all about permanent UDF. So the next we have is use case example. In yesterday's class and today's class, we have explored the different advanced topics of Hive. But how we can use these different things in our Facebook POC, in our real-time projects. So as we are talking about Facebook Hive POC, I have just written a small use case. I have just written a small requirement, and we will be writing a query for that. So first of all, let's try to understand what exactly we want to analyze, what exactly we want to find out. So the query is, or you can say the requirement is, find out the number of Facebook users from each country along with that country's currency who clicked on a technology advertisement. So this is my requirement, and I have written a query for this, that is select country, comma, get currency for country, comma, count star from click history, where add category is equal to technology, group by country. So this is a just an example. You can execute this query. This will be displaying the country name with its currency and the total number of Facebook user from that country who have clicked only on technology advertisement. So let's try to do this thing practically. We will see how many MapReduce jobs are being launched behind this query. So let me copy this command from the PDF itself. So I will copy it. Okay, one more thing is that I am firing this query on click underscore history table. If you want, you can fire this query on partition table as well. You will find the same result. The only thing is you might get some performance boost. So first of all, I will clear my screen by pressing Ctrl L. Yes. Now I will paste this query. Okay. So this query has been converted into a single MapReduce job. So it will take some time. It will find out the different unique country along with its currency and the total number of Facebook user who clicked on technology website from that given country. So it's running now. We can wait for a few seconds and then the output will be displayed over the terminal. Okay, you can have a look. Brazil is the country name, currency for this is BRL, and the total number of Facebook user who clicked on technology website from Brazil is 1444. Similarly, for Dubai, the country AED and Facebook user who clicked on technology website from Dubai is 1301. Similar details are available for India, Spain, UK, US. So this way, this is just a small example. Your client may give you very complex requirement. You have to understand the requirement, you have to load the data, you have to write the complex UDF as per the client's requirement, and then writing the query and finding out the useful statistics. And these statistics will be used by client to enhance their business. So this is just about a use case example. I am coming back to PDF now. So in this slide we will be talking about Hive scripts. What are Hive scripts? Hive scripts is nothing but your Hive commands are known as Hive scripts. Okay, till now we have executed Hive commands from Hive terminal. Can we execute Hive commands without entering into Hive terminal, without opening the Hive terminal? Yes, we can do that. Let's check it out. From the bin directory of Hive, we can type /hive -e, then the query in double quotes. Select star from employee where first name is equal to Neeraj. This query will be executed on Hive terminal and the output will be displayed over the terminal. But we are executing this query from the bin directory of Hive. You may be thinking that if we are executing like this from bin directory of Hive, or we are directly executing select star from employee where fname is equal to Neeraj on Hive terminal, what's the difference? Why we are doing this? We are doing this because this way we are in position that we can redirect the output to some output file, which is not possible from Hive terminal. Yes, that's very good thing. Sometimes you are copying the output from terminal manually. You might be missing few row, few words, that is creating some issue. Ultimately, whatever output you are producing, that you need to deliver to your client. We are doing each and everything, installation of Hadoop, Hive, queries, loading of data, just for producing that output, which we need to deliver to client. So instead of copying the output manually from Hive terminal, if we can redirect the output of Hive query to some output file, that is the best way. And that is possible only when you will execute the query from the bin directory of Hive. So coming to the second thing, /hive -e, then my query in double quotes, then greater than symbol. This symbol is used to redirect the output of Hive query to this file. You can give any file name, any extension, any path. I have given /home/Neeraj, local cluster home, Hive queries output, and use case 1_op.txt. So basically, output of my query, that is select star from employee where fname is equal to Neeraj, output of this query will be redirected to this particular output file. So the usage of every command is displayed in the pink font below that particular query. You can understand what is used for. Now coming to the next one, it may be possible that our query itself is quite big, that may be of 200 lines. So writing 200 lines of query over Hive terminal is again a error prone and a time consuming process. Because if out of 200 lines, if you will miss a single character, if you will miss a single comma, your query will be having syntax error and hence it will not be executed. So do we have anything like our query itself pick the query from some text file? Yes, that's possible. That means you don't have to type or copy paste the complete Hive query or the terminal, you can simply specify the file path, and whatever query which has been written into the query, that will be executed on Hive. So let's check it out how to achieve this feature. From the bin directory of Hive, you will type /hive -f, then the file path which contains the query, /home/nearest local cluster home Hive queries use case 1.sql. Again, you can use any extension. SQL is not required. You can use .txt. That's also fine, because it just needs the content of your file. Any file name, any extension, any path you can specify, and whatever query is written inside that particular file, that will be executed on Hive, and the output is displayed again on the terminal. Now the next requirement comes, can we pick the query from a text file and redirect the output to another text file? Yes, we can do that as well. You can have a look at the last thing, /hive -f, path of the file which contains my query, redirecting to path of the file which should contain the output. So this way we can redirect the output of the query which is written into a file, and the output will be redirected to another output file which is specified in this particular query. So there's different scenarios when you can execute the command from Hive terminal, from the bin directory of Hive. You can pick the query from a query file, you can redirect the output to the output file. These commands will help you when you get a chance to work on real-time projects. So this is all about Hive script, and with this slide we are done with Hive Facebook POC.